Everyone, it's me, Miss Lauterbach, and today our focus is understanding the plate boundaries around the Indian Ocean, particularly the island of Sri Lanka, because that's the island that we are working to build our tsunami warning system. So one of the things that we're trying to do in our investigation is understand the areas that are likely to cause earthquakes to create tsunamis. So tsunamis most often are caused by earthquakes, but not just any earthquake. The earthquake needs to be near the ocean, either under the ocean or very close to the coastline. And not only does that need to happen, but it needs to be a very strong, powerful earthquake, something that would cause a uplift in the sea floor and shift all of the water over to cause a massive flooding. In order for that to happen, it needs to be a 7.0 magnitude or higher. Anything for a local tsunami would be considered 7 to 7.9. And that would just affect a local region. So if this is the Indian Ocean right here, it would probably just affect the little islands and partially India. An ocean-wide tsunami would be a magnitude of 8.0 to 10, okay? 10 is the highest on the Richter scale for magnitude of earthquakes. So in 2004, a 9.0 magnitude earthquake happened right off the coast of Sumatra, which is the island of Indonesia. That's kind of where my mouse is floating right now. And it was such a strong, powerful earthquake that it created strong tsunami waves that affected not only the area, the islands here of Indonesia, Thailand, Sri Lanka, and India, but it traveled all the way across the Indian Ocean and flooded parts of the east coast of Africa. So that would be considered an ocean-wide tsunami of anything 8 or higher. So what we're going to do today is we are going to be labeling the convergent, divergent, and transform boundaries within our map of the Indian Ocean. So the first thing we're going to do today is understand the 3 boundaries and then map them on the Indian Ocean. So to open up our Indian Ocean, you do need to be in presentation mode. And you'll click on the link here, Mapping the Indian Ocean, and you will make a copy. Now, when you make a copy, we're going to change this name so it doesn't say copy of map of Indian Ocean. We're going to change it to your last name. I'm just going to put Lauterbach for mine. And then I'm going to have you bookmark it so that you have access to it later on. It'll be a little easier. Okay. Now, we're going to be using Google Drawing today, so you can use your mouse or you can use your stylus if you still have yours to make it easier as you draw. So the first thing is a convergent boundary. So that's when 2 plates are coming together. They'll form either a mountain range or a trench. And that trench, that subduction zone, which is taking place right along here where the plate's getting pulled underneath, that takes a lot of energy and a lot of strength to do that. And most often we find the earthquakes that will be probably strong enough to cause a tsunami will be along those trenches. So if I go to my map, I'm going to draw the convergent boundary in yellow. So to do that, I'm going to click on the line feature. I'm going to select a line and I'm going to select scribble. Then I'm going to do a little practice scribble off in the corner to see the coloring, and I want to change that color to yellow. And I also want to change the size of my scribble to 4 pixels so it's easier to see. So I'm looking for mountain ranges, and just north of India is the Himalaya Mountains. When the India plate and the Eurasian plate are colliding in, they're making the Himalaya Mountains. Off to the southeast corner of my map here at N11 is the starting point of the trench. Okay. And then over here off to the side is another mountain range that is taking place. All right. So let me just there is my convergent boundaries. All right. So going back to my slides, divergent is when 2 plates are pulling away from each other. So they're separating. It's creating actually new seafloor because that magma is coming up from the mantle due to the convection current, and when it comes up, it kind of spills out and separates. So it looks like it's stretching away from each other. It's got these like nice stretch lines from the ridge, and it'll be a mid-ocean ridge that we're looking for. So if I go back to my map, we're actually going to change that to red, and I always recommend like doing a little scribble and then changing the color, because what ends up happening is it changes the color of the boundary. And if it changes the color, I want it to do it over on the side. So a mid-ocean ridge divergent boundary right along E11. And I don't know if you noticed, but there's little grid patterns here, A through N on the top and 1 through 11. So it's kind of like playing Battleship. So on E11 is that mid-ocean ridge coming up and then kind of going to the southwest corner and down between the Eurasian plate here. All right. I think I'm going to clean that up a little bit if I can. Let's see. Didn't do a very pretty job there, but it gets the job done. All right. And then the last boundary is a transform boundary. That's when they're sliding past one another. On the ocean floor, we talked about how they're labeled as fracture zones, but on land, we have fault lines. They're kind of hard to distinguish a little bit on your map here, but if I just do my little color here, we're going to label those green. And on, let's see here, number 10, between F and K, we have a transform boundary here, and you can kind of see there might be some sliding going on. The other one that's kind of difficult to distinguish is between C6 through E4. It's off to the side there, but that is our now map of the plate boundary. So looks like our whole Indian Ocean region has all three boundaries, majority of it being convergent. So at this point, I'm going to stop the video, and the next thing you're going to do will be numbers 2 and 3 on your mapping of the Indian Ocean, which will be involving tsunami alert to look at the earthquake and the magnitude of those earthquakes, as well as recording them on your map of the Indian Ocean. Have a great day.